Hello, music fans! Have you ever wondered how Spotify is nailing it every time with music recommendation? In this video, I will explain to you the concept of K nearest neighbor, and that is an algorithm heavily used for recommendation systems. Let me start with a quick demonstration of how I've been building my own recommendation based on the Spotify web service. So here is a live script in a focused view. I'm going to search based on a query from a song that I love, times they are a-changing from Bob Dylan. It's finding it through a search. As you can see, this is the album that I love. It's getting the features, and then based on those features from the song, it's making recommendations based on a data set. Here, the first recommendation is the song itself. So, yep, nailing it. And then the second one, which is the one that I've selected here, is a French song from Charles Aznavour called La Bohème. And as you can see from this feature plot, in blue you have the original song, track number one, which is the Bob Dylan song, and in red you have the French song, and it's very close. So let me explain to you how this works. I have a short animation here that will explain the concept of K nearest neighbor. Step number one, you will initialize with a new point. And here, the problem that we are trying to solve is a classification problem where you have three classes, class number 1, 2, and 3. It could be for ranking music, for instance. And this new point is going to be essentially compared to all of the existing points on this graph. The step 2 will be calculating the distances between this new point and the existing points. And step number 3 will be sorting the distances between all of those points. Now you can select k equal 5 in this example to set the limit as to how many existing points you're going to be comparing it with your new point. And in this example, with k equal 5, in the classification problem, you would deduce that the the class for the new point is going to be class number 1 because there's more instances. However, if you take a larger number of sample, k equals 7, in this case, you will have the second class that will outnumber this first class. And this can also be used for regression problems. Here, if you want to take it from a classification, a binary discrete number of class to a more continuous problem, that's what regression is for. In this case, you could say that class number 1 is 3 stars, class number 2 is 2 stars, and class number 3 is 1 star only. Then you can have essentially a form of an average of 2.6 stars for the new song if you take 5 instances, and if you take 7 instances, you'll have here an average of 2.4, which is essentially the weighted average divided by the number of instances k equals 7. So now is time for coding. And in order for you to replicate all of what I'll be showing you in a moment, all you need is an API access to Spotify with a developer account, and I'll point you to my GitHub repo in the description. So let's go back here and switch to a full code view. And what we'll do here is essentially look at how here, based on a playlist, we can essentially extract the number of arrays. So I'm gonna here rerun all of this, look at the playlist that I've used. This is my streaming history, but you can also use another playlist from Spotify, the today's top hits, for instance. Here I've retrieved all of the features that are essentially here: acousticness, danceability, energy, instrumentalness, liveliness, speechiness, and balance. So this gives you a plot of how this track in particular is ranked according to those 7 axes. And then here is a function that will be used in MATLAB, create NS, which stands for the nearest searchers. So this is creating a searcher object with here the distance that is used in order to perform in this space of dimension 7 is going to be the cosine distance and not the Euclidean distance. There are pros and cons to different distance measure. So here you have 61 entries into this table, and we can select here k equals 5 or k equals 6, and essentially this is the KNN search that is going to be used, and you will be deriving the indices from the search, and then we'll look at here the playlist and for those indices, and you can then here change also, look at number 3, for instance, the third element, which is NG from the Rolling Stone, and as you can see here, it's also fairly close. So that was it. Let's go back and recap. So to recap, this is a pros and cons view of the k nearest neighbor. It's a bit of an equivalent of ask your closest friends for advice. Why is it great? Because it's very intuitive. There's no matrices or gradients like in other machine learning approaches. It's just figuring out who's the closest. It's very versatile, as we've seen. It works for classification, for regression in our scenario, also for recommendation, but it can also be applied for anomaly detection. There is no training time because it's essentially here just computing a new data instantly. There's no model, it's just a data set. But then there are obviously some down aspects to it. Where it's struggling is with the curse of dimensionality. At some point, if you have too many features, then you can find yourself in a scenario where all points are rated equally, and that is a problem. So here with only 7 features, it's okay, but watch out for the curse of dimensionality with this algorithm. It's also using up a large amount of memory, and each query can be quite costly, especially when you have a very large data set, because here you're comparing the query against every single point that has been stored. And the scaling matters. In this case here, I've only used features that were already scaled between 0 and 1, but in some scenario, if you have another feature like tempo, for instance, for a song, can be a large range that can dominate all of the distances compared to the other dimensions. And finally, you can also see when we've increased the number of k, it can happen that the majority class can swamp the minority. So if you have a very large amount of points in a certain class, it can completely bias the conclusion for your calculation. And that's it. I hope you liked it. And if you do, share it with your closest friends.